10.2 is pretty easy stuff. It's just finding arc measures of circles. Arc measures of circles. Let's do some of those. First, we need to get into some identifying some terms. Semicircle being a half circle. Go ahead and draw what you see because you're going to need that. Any arc that is bigger than 180, which is bigger than a semicircle, we call a major arc. Major being bigger and minor being smaller, being the small arc. Notice the difference in labeling here. We have 3 points for ADB and 2 points for AB. 3 points are needed to convey that it's a major arc, and you can see that A goes through D and then to B. That's how we identify a major arc. It is possible to name a minor arc with 3 points, but we don't typically do that. Actually, that leads to a lot of confusion, so I'd ask that you not do it. Central angle is associated with the arc. In fact, they're congruent values. Central angle is the angle. The arc angle is the same thing, but it's referencing the part of the circle. So measure of a minor arc, 50. Measure of a major arc is 360 minus that because it takes a complete circle to do, to complete the minor plus the major. Easy, easy stuff. So easy, I don't even think I'm going to do it, except maybe I'll talk about it. Arc RS is 110 degrees. I guess I will do it. RTS goes from here all the way around, and notice it's completing of the circle, so it's 360 minus 110, and I get 0, 5, 2, 250 degrees. RST, on the other hand, is going the other way. RST. Notice if we're going to say that RT is a diameter, in fact it does say it's diameter, then that's 180 degrees. It's just simply a semicircle. Two arcs of the same circle are adjacent if they have a common endpoint. You can add the measures of the two adjacent arcs. That means I have something like this. This arc right here is adjacent to this one because they share this point. Share. Whee! That means you can add up some angles to get a bigger angle. Oh my gosh, this is so easy. Do we really need to say it? But it's there. Yeah, I think I'll skip this. Got to practice to do that in class. Congruent circles. Two circles are congruent circles if they have the same radius. Two arcs are congruent if they have the same measure and they are arcs of the same circle, or congruent circles. That's just pretty much saying, say we have, I don't know why I drew a segment. Say we have a circle. Say we have another circle that's congruent. That means their radius is congruent. This is R and this is R. Let's say this has 98 degrees or 100 degrees, sure. And this is 100 degrees. Then this arc is congruent to this one because of the radius and because of the angles associated with them are congruent. So you could do the same stuff. This is just identifying values here. And I think we'll do those. Sure, I'll go ahead and do it. Tell whether the red arcs are congruent. Notice this is 80 and this is 80, and they're part of the same circle. This is a yes. Yes. Over here, they have the same angle, in this case 90, but different radii. So this is a no in Spanish. No. This is 95 and this is 95, and it tells you these segments are congruent. So this is a yes. Do you see what I'm saying? Ha. Tell whether they're, gotta practice in class maybe. That's it for this video. Alrighty.